Okay, now we will look at the second part of the force, which is 2D force into the plane. We have three forces, F1, F2, and F3, which is the F1 is on XZ plane, okay, on XZ plane, 30 degree to the Z. F2 is in X and Y plane, and F3 in Y and Z plane. Okay, so to illustrate that one, we have this one. I will show you using this box, Y, X, and Z. Okay, so the F1 will be X and Z plane, so it is on that one, so it will be that location. So you're looking from the other angle, you see it is on the X and Z plane. F2 is on X and Y plane, so it goes down to the plane this direction. If you look at from the other angle, you see right on the X and Y plane. Okay, and the last one, that is the first one, this is the F1, and the last, which is F3, will go from Y and Z, so somewhere here, maybe in the middle here, okay, from Y and Z plane. So it is actually a 2D force, but we will put today in a 3D plane. Okay, you need to resolve into I, J, and K. So the F1, of course, we have I, J, and K. That's what we want to resolve. Okay, we want to resolve into I, J, and K. Same F2, we want to resolve into I, J, and K. F3 equal to F3I, F3J, and F3K, all in I and J direction. So we look at the first one, F1, which is in that plane. Okay, we have in that plane. We want to resolve one is to X because it is on X and Z plane. So the first one will be on X plane and the second will be on Z plane. So this one will be on X and the other one will be on Z. So I'm using the, okay, we resolve one into Z and the other one into X. Since we are using the 30-degree angle, so we use one cos to the X to the Z and the other one will be sine. Okay, so the Z will be cos 30, but it is opposite direction of the Z, so it will be negative. So negative 10 cos 30 for the Z. So Z is cos, the other one will be sine for the X. So it is on positive direction of the X, so it will be positive. Then cosine 30. So we are only on X and Z plate, so there's nothing on Y. So Y will be, J will be 0. So you have to still remember, when you resolve, you want to maintain the original force right in between the two resolving force. So go back to your 2D axis. Look at this one, the second one, F2, which is 20 Newton downward on the X and Y plane. So you notice that it will be down this one. So I want to resolve into, of course, X and Y. So the first one will go to X direction, the other one will go to Y direction. So the way to resolve, you see that the first one to X positive, the other one to Y downward, so Y will be negative, and we are using 60 degrees, so the X will be cos 20 cos 60 positive. Okay, and the Y is downward, so I will have to put 20 sine 60. Because it is downward of positive y, so we put negative 20, and z will be 0. The third one, f3, which is on plane y and z, so one into z and the other one into y. And once we resolve this one, both goes to positive direction of y and z. Make sure you maintain the original force in between the two resolving force. Okay, if you still remember this one, if you have one force, resolve into x and y, so one will go to x, the other one go to y. Okay, we maintain the original right in the middle, so we use the same concept here. So one there and one into x. Actually, we maintain the same concept in this 3 dimension. Okay, so the f3, I want to use 45 degree, so the 45 goes to y direction, so there will be nothing on x, so x will be 0. So we have 100 cos 45 because you use 45 degree to the y. Okay, and then the other one will be 100 sine 45. Okay, resolve one to z and the other one into y axis. Okay, that's how you resolve the 2D force into 3D plane. You have to resolve everything in I, J, and K. The one that don't have the direction there, you will put 0. Okay, in that direction. The others you have to put the, if there is negative, you have to put the negative. So later on, when you want to add the force, you have to add in I, all in J, and all in K. That's all. Thank you. So now we have seen the first two, which is first angle method. No, the 1D force and 2D force. Now we go to the 3D force in 3D plane. And for the calculation and analysis of 3D force, we have 3 different methods, which is first angle method, second angle method, and also coordinate method. You cannot choose which method you want to use, but the way you choose is because of the type of information given to you. So you have to use one of these 3 methods based on what information that you have. Not that you don't want to study the 2 methods, you only want to study this one. No, you have to study all, because based on the information given to you, you have to pick which one is suitable to be used. Okay, so the first one is the first angle method. We call it as first angle method, where we have if the information of angle between the axis and the forces and the force is given. All is given. Let's say here we have from y to the force, we call it theta y. From z axis, from x axis to force theta x, and from z axis to force, we call it as theta z. So if all these 3 is given to you, you can use first angle method. If maybe only 2 is given, okay, you still can use the first angle method by using the vector identity. Where we have cos squared theta x plus cos squared theta y plus cos squared theta xy z equal to 1. Okay, cos squared theta y, theta x, theta y, and z equal to 1. So let's say the question only gives you theta x and theta y. You can still calculate the theta z using this formula. So in other way, if 2 of this angle, which is from axis to the force, is given to you, or the 3 is given to you, you can use the first angle method. Okay, to visualize this one, okay, actually this force is, I'm putting this force from here 0, 0 towards this one. Actually this force is on this line. Okay, this is where the force go. Okay, this is where the force go. Okay, this is x, this is z, x and y direction. So the force go to this line. Okay, it doesn't matter it is right here or somewhere here or somewhere here. It doesn't matter. Okay, or it's go to down this way. As long it is three axis. Okay, 3 dimensions. So let's say it goes there. Okay, so the angle that I'm talking about is here. The one that is given to you, for example, from y-axis to this line. This angle is given. This is theta y. Okay, this angle is theta y. From x-axis to this one, line from here to this one, this angle is theta x, and from this line to this axis, this angle is called as theta z. Okay, so theta x, theta y, theta x, and theta z. If these 3 angles is given or 2 is given, you can calculate. You can use the first angle method. Okay, so what said for the first angle method? Let's say this is f. So how you resolve this f into ijk? What we want to do is we want to have f equal to fxi plus fyj plus fzk. Okay, if you use this first angle method, meaning that the angle is known, so you will use f equal to, remember from 2D force, okay, we take this, let's say, from the force to the line, we will use the cos. Okay, so what we do here is f times cos theta xi plus f times cos theta y j plus f times cos theta z k. Okay, that is how you convert the 3D force in 3D plane in terms of I, J and K. Okay, so you need to know is you have to know the angle between the force and the axis, theta x, theta y and theta z. And if one didn't know, you can calculate. After that, you transform using this formula into I, J and K. Okay, let's go to the example.